Assalamu alaikum wa rahmatullah. Hi everyone. In this video I will be solving question 2 from the file of the second question of the coverage of a grade 11 elite. So the radius R of a sphere is increasing at a constant rate of 0.04 centimeters per second. Know that the volume of the sphere is given by V equals 4/3 pi R cubed. At what time, or at the time when the radius of the sphere is 10 centimeters, what is the rate of increase of its volume? Now, what's happening here? We have a sphere, right? And that sphere is having a radius, let's call it R, right? So because the radius is increasing, that means there is a change, dr over dt, which is given 0.04. Now, because the radius is increasing, the volume will increase, so we have dv over dt. This is what we need to find in the first part. So, to do part A, let's start by writing the volume. The volume is 4/3 pi r cubed. It says, what is the rate of increase of its volume? يعني find dv over dt. So let's differentiate both sides with respect to time. So this is dv over dt equals this amount here is constant. So just leave it in front, okay? It's a coefficient, 4/3 pi. Now what's the derivative of r cubed? It will be 3r squared dr over dt. We can cancel the 3 and this 3. Now to find dv over dt, we will substitute. Here we have 4 pi and the radius given, it's 10. So this is 10 squared and dr over dt is 0.04. This is equivalent to 16 pi centimeter cubed per second. So the rate of increase of the volume is 16 pi centimeter cubed per second. This is part A. Part B says, at the time when the volume of the sphere is 36. This is the volume of the sphere is 36. What is the rate of increase of the area of the cross section through the center? The cross section of the sphere through the center is going to be a circle. So we are looking for dA over dt when the volume is equal to 36 pi. So first we need to find the radius at that volume. It is 4/3 pi r cubed. This is the volume formula. Now the volume equals 36 pi given in part B. This is 4/3 and this is pi and this is r cubed. Now what happens? We can cancel this one and this one. We can multiply by 3/4 here and there. So 4/3, this is 3/4. Okay, so this is equal to 27. 36 times 3/4 is 27. 27 equals r cubed. Take the cubic root of both sides, so r will equal to 3. So we need to find the rate of change of the area when r is equal to 3. We know that the area of the circle, which is the cross section through the center, is given by pi r squared. So dA over dt is equal to 2 pi r dr over dt. We can just now substitute. This is dA over dt. It's equal to 2 pi times the radius we found it, which is 3. dr over dt, it's 0.04. It's given, right? So this is 0.24 pi. It's an area, يعني centimeter square per second. Rate of change of an area. 0.24 pi centimeter squared per second. This is part B. Part C, at the time when the volume and the radius of the sphere are increasing at the same numerical rate. شو يعني؟ It means that dr over dt will equal to dv over dt. At that time, at that moment, find the radius. Well, because we have V and R, we can use the formula of the volume for part C. We know that the volume equals 4 over 3 pi R cubed. And we did differentiate in the previous part, or part A. We've got 4 pi R squared dr over dt. Now, because they are equal, we can cancel it from both sides. We can cross out dr over dt with dv over dt because they are equal. The question says they have the same numerical value. So dv over dt, it will be cancelled. That is 1. This is 4 pi, and this is r squared. Divide by 4 pi. Divide by 4 pi. So r squared equals 1 over 4 pi. To find r, we can just take the square root of both sides. So r will equal to positive 1 over 2 root of pi centimeters. That is the radius. This looks v, but it's r. Let me just rewrite it. This is the radius, 1 over 2 root of pi. That's it for this question. Good luck.